This is a ZenoLink data view analysis for Chris Thomas, baseball swing, collected in November 2012. We take a quick look at our performance profile and few key numbers. Performance factor telling us how effective the hitter is utilizing peak speed output or power output. And obviously very high at 195, 98% utilization linear, 97 angular, good speed outputs at both angular and linear. So overall, good effective use of speed at impact. We look at the kinetic link, we can see how that speed is being produced, and we see a really good basic kinetic link. This kinetic link is there's areas of weakness that we can improve, but this is what you like to see from a hitter. You'll see lower body driving, upper body driving the arms, driving the bat, and you can see when that occurs, you not only have top speed output, which is fantastic, very high end, but it's a very efficient process, which means more consistency, less holes in the swing to be exploited by pitchers, and obviously just overall more power. But you'll see where we could improve is lower body contribution and the relationship between the lower body here and the upper body. That's going to be our main focus. The arm bat dynamic is fantastic. So we'll take a look at stability. Here we have pretty much what we expect as far as stride mechanics. Distance is right on the money. So the length of the stride, the direction of stride, maybe a little straight, let's say maybe a few degrees more close, get a little bit more out of the lower body. And that's one of the things that we can start to work on is getting a little bit more out of the lower body. Something as small as changing that stride to be just a few degrees more closed, literally a few degrees, will give the body a little bit more ability to translate ground reaction force into torque. Posture's pretty good. Nice upright posture, staying in posture, a little extension, but not too much, great. Starts off with a little bit of left bend going into right bend, not too much right bend, looks good. So, generally posture, the stability part of it's good. We want to improve our core integration and core dynamic. Muscular loading, and this is where you'll see that we're not, as good as some of this stuff looks, we're not really dynamically engaging the core musculature where we would expect to see. We get kind of engaged early. So as we improve some of the facets of lower body mechanic, core dynamic, both stability and coordination, we're going to get better muscular activation and contribution. Upper body load is actually pretty decent, but we can make it better and get more out of those muscles, get more speed production. But this relationship is pretty good. Just like to see a little bit better decel facilitating a stronger acceleration of the upper body, but muscular engagement and the timing of that's pretty good. We look at bat dynamics. Pretty much what you'd expect as far as utilization output is pretty high, obviously. But the direction of applied speed isn't quite as good as it could be. So as the bat's coming into contact with to the ball here, let's move them along to impact. Collision, you'd expect, you see most of the speed is just squarely bang right into the ball. Y is right on the money. You want just virtually nothing but just a little bit of inside. But there is a little bit of a little bit too much kind of outside in speed. Although this could be a pull hit, he's hitting it a bit out in front of the plate. We could reduce this by just a little bit. You still get a pull hit, but you'll minimize or maximize the compression a little bit. But all in all, this is really good. So really what we're focusing on is getting more out of the lower body, connecting through the core a little bit better, engaging the core musculature, and funneling that speed to release, working on improving the utilization of the bigger muscles, lower body and core, to drive arms and bat. But all in all, looks really, really good. What we're doing here is just improving and building off of a pretty good basic mechanic.